Hello everybody, my name is Walter and this is episode 5 of my Redstone Commands Series. In this episode I want to talk about target selectors, which are a fundamental part of many commands that deal with entities. I will concentrate on the target selectors for the Java edition, since the Java edition is what I usually deal with and the Bedrock edition deviates a bit. It's generally pretty similar, but there are some noticeable differences, so if you are playing and working with commands in the Bedrock edition, you may want to have a look in the Wikipedia article. Link for that's in the description. But anyway, let's get started with this episode. So, first things first, before I actually get to the target selectors, I need to talk about identifiers. So, what are identifiers? They are effectively the name of an entity that Minecraft uses to do whatever it does in the background. For players, it's pretty simple, it's the player name. For all other entities, it's a string of letters and numbers that follows a certain pattern, but is not really intuitive, and the only real way to find the name or the identifier of an entity is using the autocomplete function. So if you look at an entity and you want to know the name of that entity, you can use, for example, the data get command. We work with an entity and then you get a list of the 5 different target selectors. More about those in a few seconds. Then you will usually get your own name, and then you get the name or identifier of that specific entity you are currently looking at. And as you can see, long string of letters and numbers, there is a bit of a pattern, but you can't really tell beforehand what the name will be. So yeah, you can use it manually, which is quite good if you want to test things out. So if you want to know what a specific command does, or you want to play around with NPC data also, this is usually the way to go. But if you're working with data packs, or you don't know the name of an entity, or you want to work with a multitude of entities at the same time, you will have to use target selectors. Now, target selectors follow a very simple pattern. They are just 2 characters long. The first is an at, and following that you have a single letter. 1 of 5 in the Java edition, and I believe 1 of 7 in the Bedrock edition. The simplest one likely is the so-called self-selector, or @s, which is specifying the entity that is currently executing the command. If the command is executed by a command block, you will get a simple error message that it didn't find or couldn't find an entity. So the command will not be executed in this instance. You can change who is executing the command using the execute as command. So in this example, you will get a bit more details about this part later on, but essentially I'm going for all items that are at most 2 blocks away. And run on then the data merge command to change the upward speed. What does this mean? Well, let's show this in action. And you can see I basically have an item trampoline. A rather nice side effect of doing this is that you can circumvent a limitation of some commands. For example, the data merge command can only work with a single entity at a time. So if you were to try to use the data merge command on a multitude of entities at the same time, you would get an error message. This wouldn't even pass. So what can you do? Well, the execute as command basically splits whatever follows into different branches, each running on one of the selected entities. And subsequently, you can now use the self-selector, which at all times only selects one single entity. And subsequently, you can essentially circumvent this limitation of, for example, the data merge command and other commands. Next, we have @p, which stands for the nearest player, or the player closest to the position where the command is currently executed at. So quite common use are teleport commands, so teleport stations where you usually only want to teleport the player that is actually standing on top of the pressure plate, directly on top of the command block. And you can see I get directly upwards. Now the meaning can once more be changed using the execute, this time @ command. So in this case, I'm going for the nearest armor stand. And from that new position, I'm running the teleport command. So if there were a player even closer to the armor stand than myself, and if I press there, that player would be teleported up to here. In this instance, well, since there is only one player in this world, I get teleported in either case, but as you have already seen, I will not be teleported on top of the command block, but since I changed the position of the command execution on top of the armor stat. Next, we have the random player selector at R. This gives you back a randomly chosen player on the map, which is quite commonly used for things like, well, games of chance or lotteries or mini games or such. So here, for example, I would give a random player a couple cookies. Since I am the only player on the map, it defaults to me. So, yeah. Following that, we have the all player selector at A. Now, this is the first of two selectors that can give or will give you back more than one single entity. Subsequently, some commands won't accept that because some commands are limited to a single entity, like, for example, the data get command. And the moment you try to give it more than one entity, you actually get an error message, since it only is allowed to work with a single entity. Subsequently, you will have to filter it down until you get a single entity, or you will have to use the trick I showed you earlier with the execute as command to basically branch it out and then have one branch with a single entity. The teleport command, for example, works with multiple entities. In this instance, you would teleport all players that are on the map right to the position in front of this command block here. But in most instances, you would want to filter it further down, for example, all players in a certain area or similar. Next, we have all entities at E. Now, this is even broader than all players because this now means really all currently loaded entities. The problems with commands that work on only a single entity are the same as with the all players. And there are not many commands where it really makes sense to teleport every entity or to work with every entity in the game. So maybe the glow command or the glowing effect, you can see some items, for example, won't even accept that since it's not applicable to them, but armor sets, for example, can get the glowing effect. But in most instances, you would want to filter it further down to actually get a usable subset of the entities. And that's where this command actually becomes really, really powerful. And that brings me to the last part for today, which are target selector arguments or filtering. So what is that about? Well, sometimes you don't want to have all entities that are selected by a specific target selector. And in those instances, you can add additional conditions that need to be fulfilled for the entities to be selected for. You can even filter it down until no entity is left over, at which point the command execution simply stops. This is essentially what happens here, even without any target selector arguments with the self-selector for a non-entity. Some of those arguments can also be repeated several times. So for example, you can say, okay, I don't want any players and I don't want any armor stands, but everything else, just as an example. The way to write it down is pretty straightforward. You start with the actual target selector, and then you have in rectangular brackets the arguments, one after the other separated by commas. The comma here effectively means an AND. So whatever is selected for needs to fulfill argument 1, argument 2, and whatever follows. An argument has three parts. The first is the name of the argument. Then you have an equal or an unequal, which is the equal and exclamation mark. And then you have either a value or a range. The value can be just a number or it can be some kind of text. And the range has as its defining part this double point and then an optional lower and upper limit. You can limit it between two limits, or you can give it just one of those. You can say, okay, greater than A or lower than B. It doesn't make much sense to leave out both limits because then you're not limited at all and you could leave it out completely. So yeah. And with that, let's talk about the different arguments you can actually use in Java Edition. I'm grouping them in the same order or same way that it is done in the Wikipedia because it makes the most sense. And I will start with the position arguments. So let's start with this here. This would kill all players that are in a certain area. Now this area has the reference point with those XYZ coordinates. So you can see this is absolute world coordinates effectively separated into 3 arguments, which is essentially this corner here, or this block there. And following that, you have dx, dy, and dz, which define the size of the cuboid area. So those are the relative sizes relative to this reference point. In this instance, it's effectively the part of this floor here, which well, is effectively lava. And that's about it. So you define a cuboid area and you can define where the cuboid area starts. You can also have negative numbers in there and you can work with decimal numbers. Works nicely this way. If you don't define the X, Y, and Z, it defaults to the position of command execution. So, or the center of mass, as I have explained it in the previous episode. So for a command block, the lower northeast corner. For an entity, right at the bottom middle of the hitbox. The second is distance. This is, as the name implies, the distance to the center of mass to the reference point. Center of mass for entities, as I said, right in the middle of the bottom of the hitbox. You can also add the X, Y, Z to this. If you do that, you change the point or the center of where the distance is calculated from. So essentially you could make a deadly bubble somewhere else than right around this command block. Or, well, in this instance, for example, here I would kill all players that are further away than 46 blocks. So you can use this, for example, to make a deadly area around, so a lethal world border or something like that. The X, Y, Z coordinates also affect the sorting, but we'll come to that a bit later. Next, we have scoreboards. So there is quite a few things that are related to scoreboards, so the scores, tags, and teams. All of those are quite useful when you're working with mini games and similar, and can be used as filters for target selectors. So in this instance, just a simple example, I'm going for all players that have a score of enemy kills greater than 10, have a score of got killed less than, or at most 5, and are in team number 1, and don't have the leader tag. And those get 10 cookies. So just a simple example there. Then what the wiki calls entity species. So the first is the name of the entity. Now the name of the entity is the identifier I talked about in the beginning of this episode. So for example, the name of the player. Now why would you want to do that? Well, it allows you to further filter down. As an example, if I were to use just the player name instead of a target selector, I couldn't add further conditions to it. I can add further conditions if I use the target selector with the name argument. So in this instance, it would teleport me only if I were closer or at most 2 blocks away. Type is one of the arguments I use most of the time, and this basically allows you to define who is actually affected by this argument or what type of entity is selected. This is one I use pretty much all the time when I'm working with the all entity selector. You can select for a lot of things. You can select for certain groups of things, like for example, all error types or well, all impact projectiles, or for specific things like armor stands or different mobs, or you see there are loads and loads of things like items, item stands, item frames, and such. So many, many things you can select for. And a very powerful tool, especially if you work with the all entity selector. And predicate is something I haven't used yet, but it essentially allows you to define or predefine inside of a data pack certain conditions that can be checked at the point where you're using them in an argument for a target selector. Then we have entity data, essentially NBT data, and here, since they are quite useful and commonly used, X rotation and Y rotation have their own name. X rotation is basically whether you are looking up or down, and Y rotation is the direction you're looking in the horizontal. NBT data can be basically anything in here. You can, for example, check whether a certain entity is invisible or moves in a certain way or whatever. So you can check for several things. Just as an example here, I'm checking for all players that are looking straight down, and if they do that, they get a simple message. Now you may ask, why would you want to do that? Well, it can actually be quite useful. I'm running a data pack in the background actually that gives me quick access to, in this instance, 3 things. So I can easily get a command block, structure block, and can access my brush data pack without having to remember how the corresponding commands were. So can be a bit of a shortcut if I want to access certain things all the time. Then we have things that directly deal with players and player data. So you can check, for example, for cheaters in the game. So if you find a player that has more than 1,000 levels of experience, well, then you can do away with them. Or if someone is in a spectator mode and you don't want anyone in the spectator mode, or you could change the spectator mode, the game mode of them then. Or let's say you are selecting for players that have never entered the end, but have already killed the Ender Dragon, which is a bit of a strange combination. So you can select for certain players. And the last is limiting and sorting. So sort and limit usually belong together. You will usually only use them together. And basically they do what they names imply. So sort sorts the list of possible entities, and limit then further limits the list to a certain number of those. You can sort in 4 different ways. Arbitrary is order of creation. Furthest is distance, or the furthest away from the reference point, which you can change, remember, with the x, y, z coordinates or arguments. Nearest is the nearest, obviously, and random is randomly chosen or randomly sorted. And limit then, as I already said, is limits the number of entities that are selected from this list, starting at the top of the list, essentially. And what you can see here is, if you limit it to 1, you can get around, or you can work with commands that usually only accept a single entity, because now you are forcefully limiting it to a single entity. So data get command with limit of 1 would work. With a limit of 2 will get you an error message. And what you can also see here, there is a bit of an overlap with other selectors. So if you were to use the random with limit 1, you would have the add R selector effectively if you started with the add R with all players. And nearest would be the add P selector for nearest player. So you can even rebuild the more limited selectors using the sorting, for example. And with that, we have reached the end of this episode about target selectors. I hope you enjoyed this little episode, and well, see ya!